So Paula is a research associate at Fraunhofer Institute for Process Engineering and Packaging, IVV, based in Freising, Germany. She works at the Department of Material Development in the field of biopolymers to improve existing packaging solutions and develop new ones. She graduated from Technical University of Munich with a master's degree in food technology. While working at Fraunhofer IVV, she earned 2 awards for her achievements, congratulations, with her master thesis on development of water-soluble milk capsules for application in coffee and tea. Her presentation title is Proteins as Bio-Based Coatings for Packaging. And please, Paula, the floor is yours.
So thank you very much for the introduction. I'm part of the EcoFunco project, and I'm going to talk about proteins as bio-based coatings for packaging and how we use it in the EcoFunco project. First, let's take a look at the agenda. I'm going to give a quick introduction of the Fraunhofer IVV and our work field. Then I'm going to talk about the challenges faced with sustainable packaging today and how protein-based coating can be a possible solution, and how we use a micellar lupin protein in EcoFunco to find a solution. So the Fraunhofer IVV has 2 locations, one in Freising and one in Dresden. And by now we are a pretty big institute with a total workforce of 325 people. And at Freising, we have different business fields all around the topic of process engineering and packaging. And the field of packaging is somehow an overlap of all these business fields where we're working on all kinds of packaging solutions, and in my group especially with biopolymers. So there are different possibilities to face the challenges that come with sustainable packaging. As you can see, there are a lot of different possibilities, but I want to focus on the biodegradable and the bio-based solution. Of course, there are also problems coming with new solutions. For example, is a raw material in competition with food, or maybe has the new material less gas barrier. That the gas barrier is pretty important. You can see in this graphic here on the right. There are a lot of requirements for sensitive food, pharmaceuticals, and technical products, and a lot of demands regarding the barrier. But at least the oxygen barrier, the demands regarding the oxygen barrier can be met by protein coatings. One example here is the whey protein. Now, as I said, most of the times there's a need for an oxygen barrier in a packaging, and usually this is fulfilled by a thin layer of EVOH. But EVOH can be replaced by a protein layer, for example, whey. With that, values of 1 to 2 cubic centimeters per square meter per day in bar can be reached. It is also competitive regarding the raw material price and applicable in industrial scale. Here you can see examples of OTR values that can be reached with different types of proteins. Here, the whey protein that I just talked about, but also right next to it, micellar lupin protein, which we are mostly using in the EcoFunco project. Micellar lupin protein is some kind of a special protein. Lupins are mostly used as green manure, and the protein-rich seeds are not valorized to a large extent. this brings me back to the point in the beginning that protein shouldn't necessarily be in competition with food, which isn't the case here, which is pretty good. But the protein can be extracted from the seeds by a specific extraction method, which includes a combination of salting in and dilution precipitation. This forms a micellar protein. With this alteration in the tertiary structure, hydrophobic groups become exposed. This also has an influence on the protein properties. The micellar protein has a low water solubility, high stickiness, a fat-like structure, and a structure viscous behavior. With the combination of two of those properties, the oxygen barrier and the adhesive properties, in one single layer, the amount of material used can be reduced while improving biodegradability and recyclability. You can see it in the scheme. I'm very sorry, I somehow forgot to translate it into English, but I think you can see that the amount of material used can be reduced in theory. Here you can see a quick overview of the process. Here 2 types of proteins compared, because you can not only form a micellar protein out of lupine, but also out of sunflower, as you can see it in this example. But when you compare the 2 proteins, you can see that lupine has an overall higher protein yield. That's also why we chose it for EcoFunco. So up until now, the micellar lupine protein was only used in water-based formulation, but this brings a few drawbacks. When polymer-polymer structures are supposed to be laminated, the water can evaporate. Like if we would laminate polymer against paper, the water remaining in the formulation could evaporate easily through the paper. But the remaining water has a negative influence on the bond strength and the oxygen barrier. That means that the formulation needs to be adapted without destroying the micelle and therefore changing its properties. So in EcoFunco, we tested different combinations of solvents, tensides, and plasticizers to try to laminate polymer-polymer structures. Here you can see the results of the development of the solvent system. First, it turned out that water, or at least a certain amount of water, is essential for the protein stability. So we can't replace it completely, but at least in parts, we can replace it with ethanol or ethyl acetate, so that these solvents can evaporate a lot more quickly than water. But it can also lead to protein aggregates, which you can see here. So we will also need some tensides, like, for example, triethanolamine or diethanolamine. Those don't have an effect on the micellar structure, which is very good because that would change its properties. But if used in the wrong amount or the wrong combination of solvent, water, and tenside, it can lead to phase separation, which you can see here. Another important part of the formulation are plasticizers. In the project, we tested different plasticizers like oligolactic acid and polyols for the compatibility and influence on the performance of the coating. As you can see here, the plasticizer has a big influence on both bond strength and OTR. So we tested in different laminates with different formulations regarding the tensides and the solvents, and here we tested. Here are the different plasticizers shown. The OTR is calculated for the coating on its own, so without the substrates and it is standardized to a thickness of 100 micrometer to make it comparable. So here you can see the microatom cuts that we did to determine the coating thickness. You can see here, this is the substrate, this is substrate, and here the light part in the middle is the protein coating. This is how we determine the coating thickness. We also tried to find the perfect amount of protein concentration, because as you can see here, OTR and bond strength improve the higher the protein concentration is. This is expected and logical, since the higher the protein content, the better is the bond strength and the oxygen barrier, since less moisture has to evaporate. But it is also important to not that the protein concentration is not too high, because obviously then the formulation will get too viscous to then it can't be processed anymore. It always depends where it should be processed, but it shouldn't exceed a certain level of viscosity.
Excuse me, Paula, you have 4 minutes left. Thank you.
Okay, perfect. Because this is my conclusion. So you can see that protein-based coatings can fulfill a lot of barrier requirements while being bio-based and biodegradable, and also sometimes can help with recyclability. Micellar lupine protein has specific properties because of its structure, and it can combine two of those properties, the oxygen barrier and the adhesive properties, in a single layer, and therefore the amount of material used can be reduced. But the micellar lupine protein formulation needs to be adapted when a polymer structure is supposed to be laminated. Those adaptations can have a major influence on the protein properties and need therefore be done wisely. This is it from my side. I'm open to questions.
Thank you, Paula, for your presentation and for explaining us the possibility and advantages of protein-based coating in terms of sustainability of packaging products.